Hello fellow viewers, welcome back. So this is from a request from my friend. I'm going to go through a few practice questions for chemistry. This is mostly all just calculations and all that. So let's begin. When a metal carbonate MCO3 is heated strongly, it decomposes to form a metal oxide. When 39.4 grams of MCO3 is heated strongly, 48 dm³ at room temperature and pressure of carbon dioxide is produced. What is metal M? Okay, first of all, we need to find... Okay, what we can find out is the moles of carbon dioxide. So 4.8 dm³ divided by 24 will equal to 0.2 moles. That's how many moles of carbon dioxide I have. Oops, my bad. So now we can compare carbon dioxide to MCO3. So therefore, MCO3 compared to carbon dioxide, and I'll get, the ratio is 1 to 1. So if I have 0.2 moles of carbon dioxide coming out, then I'll have 0.2 moles of MCO3. And over here, I do know that I use 39.4 grams of MCO3. So the MR of MCO3, so the mass, the known mass, divided by the MR will give me 0.2 moles. Okay, so here's what I want to find. I want to find the MR. So the MR will equal to 39.4 divided by 0.2. And that'll give me 197. So therefore, I need to now find the MR of carbonate, because I want to find the AR of M. So the MR of carbonate is just 12 plus 3 times 16, which is 60. So therefore, the AR of M will equal to 197 minus 60, which will give me 137. So if we look at the periodic table, the element with the AR 137 is barium. So therefore, M is barium. That's question 1 done. Okay, let's move on. You are given 250 cm³ of 1.5 mole per dm³ of hydrochloric acid. How much water must be added to the hydrochloric acid given so that its concentration is reduced to 1.0 mole per dm³? Alright, so let me visualize this out for you. I have 250 cm³ of a 1.5 mole per dm³ hydrochloric acid. I need to turn this into a 1.0 mole per dm³ concentration hydrochloric acid. So therefore, I'm going to have to dilute it. I need to add water. So first things first, I'm going to find out how many moles I even have in 1.5 mole per dm³. So therefore, it is 1.5 mole per dm³ times 250 over 1000, which will give me 0.375 moles. Okay, now when I add water, the number of moles actually don't change. Let's say I have, like, for example, I have 4 moles in this solution. Even if I add water, the whole solution will still only have 4 moles. So the amount of moles does not change when I dilute the solution. So therefore, if I want 1.0 mole per dm³ solution of hydrochloric acid, I just need to find out how much is the volume. So I'll take 0.375 divided by 1, which is the mole per dm³, which will give me 0.375 dm³. That is the known volume for 1.0 mole per dm³. So now we've got this value. We're just going to take that value minus the original value here, so that we can find out how much water was added. And that'll end up giving me 0.125 dm cube. Alright, or you can write this as 125 cm cube. Alright, next question. Magnesium ribbon reacts with hydrochloric acid as shown in the equation. Okay. A 0.24 gram sample of magnesium ribbon is added to 5 cm cube of 2.0 mole per dm cube hydrochloric acid. Which reactant, magnesium or hydrochloric acid, is the limiting reactant? Alright, so I have 0.24 grams of magnesium ribbon. So that would mean that I will have 0.01 moles of magnesium. Alright, and now we can compare the ratio. So magnesium to hydrochloric acid, the ratio is 1 to 2. So if I have 0.01 moles of magnesium, that would mean I have 0.02 moles of hydrochloric acid. Alright, so now let's find out how many moles the hydrochloric acid has. So 2.0 mole per dm cube times 5 divided by 1000, which will give me 0.01 moles. So therefore, if my hydrochloric acid has 0.01 moles, that would mean that my magnesium would just need 0.005 moles. And therefore, we can see that there is still excess magnesium left. So therefore, hydrochloric acid is the limiting reactant. Alright. Okay, moving on, part B. Calculate the maximum mass of magnesium chloride that can be formed in this reaction. So we know... Okay, now we're just going to compare. Okay, so we know that there's only 0.01 moles of hydrochloric acid. And the ratio is actually just... The ratio is just 2 to 1, so it will be the same as above. Maximum amount of moles that magnesium chloride can form is 0.005. So we need to find the MR of magnesium chloride, which is 24 plus 71, which will give me 95. So therefore, to get the mass, as we remember, mass equals to MR times mole. So 0.005 times 95, which will give us 0.475 grams. And there you go. That is the maximum mass of magnesium chloride that can be formed from this reaction. Moving on. Alright, over here we have a diagram. The following reaction scheme shows information about the reactions of copper and its compounds. So over here we have 8 grams of copper reacting with 2 grams of sulfur with heat, and that forms 10 grams of compound X. Okay, so let's work on that first. By calculating the mole ratio of copper to sulfur, find the chemical formula of compound X. Alright, so we're going to compare copper to sulfur now. Over here we have 8 grams of copper. And for sulfur we have 2 grams. So to find the amount of moles is just mass over MR, so it's just 8 over 64. And for sulfur it's just 2 over 32. So that'll give us 0.125 to 0.0625. So we will divide by the smallest number, which is 0.0625. So we'll end up getting 2 is to 1. So our formula, our chemical formula for compound X will be Cu2S. Alright. Next question. X reacts with oxygen to produce a black solid Z, which is copper oxide, and a colorless gas Y. Identify the colorless gas Y. So X, as we know, is Cu2S. And it reacts with oxygen to produce a black solid, which is copper oxide, and a colorless gas, which is Y, which we don't know yet. So right now I'm just going to even out the equation. So there's 2 here. So now I know that Y has to contain sulfur. because there's no sulfur on anywhere else. And since on the right side, my products, there's only oxygen, there's only 2, and on the left side, there's also 2. So my Y is a gas, so it's most probably that my Y equals to sulfur dioxide. Yeah, Y equals to sulfur dioxide. Okay, easy. Now next question. Explain with the aid of an equation why the mass of compound X and the mass of solid Z are the same. Okay, with the aid of an equation. So what we need now is to compare mass of compound X and solid Z. So now we're just going to compare them to see. Oh, so the ratio is 1 to 2. And okay. So the ratio is 1 to 2. So when I have 1 mole of this, I will have 2 moles of this. So I'm going to find the MR of Cu2S, which is just 2 times 64 plus 32, which is 160. All right. That's 160 there. And the MR of CuO, which is just 64 plus 16, which is 80. So therefore, to find the mass, we know that it is MR times mole. So therefore, for this one, for Cu2S, it is 160 times 1, which will give us 160 grams. And then for this one, it is just 80 times 2, which will give us 160 grams. And that is why the mass is the same. Mass of compound X and the solid Z is the same. There you go. Next question. Sodium hydroxide reacts with sulfuric acid according to the equation. Solution A contains 4 grams of sodium hydroxide per dm cube. Solution B contains sulfuric acid. In an experiment, 25 cm cube of solution B reacted with 18 cm cube of solution A. Calculate the concentration of B in moles per dm cube. Okay, so the information we know now is that the concentration of the sodium hydroxide is 4 grams per dm cube. So that will just give us 4 grams per dm cube. That's the concentration. Okay, so to find this in moles, we just have to divide it by the MR of sodium hydroxide, which is just 23 plus 16 plus 1, which is just 40. So that'll give us 0.1 mole per dm cube. Okay. And over here, we do know, sorry, my bad. Yeah, sorry. Okay. In experiments, 25 cm cube of solution B reacted with 18 cm cube of solution A. So we know that there is 18 cm cube of solution A here. So we just have to multiply this. 0.1 mole per dm cube, sorry, I forgot the cube sign, times 18.0 divided by 1000, which will give me 0.0018 moles. Okay, and as for sulfuric acid, that would mean that 25 cm cube of solution B will react with this amount of moles. So from our ratio up there, NaOH to sulfuric acid, ratio is 2 to 1. So over here 0.0018 to 0.0009. Okay, that's how many moles of sulfuric acid we have. So over here we know that we use 25 cm cube of solution B. So therefore concentration equals to mole over volume. So it's just 0.0009 divided by 25 over 1000, which will give us 0.036 mole per dm cube of sulfuric acid. That is our concentration of B in moles per dm cube. Alright, let's move on to part B. Calculate the concentration of B in grams per dm cube. Okay, so we do know that mass equals to mR times mole. So it works the same for concentrations too. So now we do know that B has a concentration of 0.036 mole per dm cube. So to make it into grams per dm cube, all we have to do is to multiply by the mR. So the mR of sulfuric acid is just 2 plus, sulfur, can't remember, sorry, 2 plus 32 plus 4 times 16, which is 98. Alright, so 0.036 times 98 will give us 3.528 grams per dm cube. That's our part B answer. Alright, let's move on to part C. I'm going to use a different pen now. Calculate the number of grams of SO4 2- ions in 1 dm cube of solution B. Okay, I'm going to use so we do know that the concentration of solution B is 0.036 mole per dm cube. Now we're just going to use 1 dm cube of it, which will just mean that we have 0.036 moles of sulfuric acid. Okay, so in sulfuric acid, it is composed of hydrogen ion and sulfate. So the ratio here is actually 2 to 1. So since there are 0.036 moles of sulfuric acid, that means for sulfate, there will also be 0.036 moles. For the hydrogen, that will be 0.072 moles. Okay, so they want the number of grams. So now we have the moles. So remember, mass equals to mR times mole. So now we just need the mR of sulfate ion, which is just 32 plus 4 times 16, which is 96. So therefore, mass of sulfate ion will equal to 0.036 times 96 equals to 3.456 grams. And there you have it. That's our final answer. So I hope these practice questions can help you understand a bit more on concentration and dilution. So thanks.